on isotopes.
So, the periodic table. I want you to start understanding the periodic table. And so in order to do that, we need to understand what are all these numbers and symbols for? What does it all mean? So today we're going to kind of break that down. And then from doing that, we'll be able to learn about isotopes, which is what I really want you to get from this concept. So, periodic table notation. So typically when you're looking at a periodic table, there's several things that you're going to see. First is the atomic number, and this tends to be at the top, either the center or the top left or the top right. And this tells the number of protons in an atom of the element. This is how Henry Moseley organized the periodic table of elements. He organized them by atomic number. So if you looked from the top left to right and keep going down row by row, you'll see it's organized 1, 2, and then the next are 3, 4, 5, etc. And it keeps going in that order. So memorize, memorize, memorize. It tells me the number of protons. Also, know that this is what is used to identify an element. If an atom of an element has 1 proton, we know it's hydrogen. If it has 3 protons, we know it is lithium. If it has 2, we know it is helium. This is what determines whether or not an atom is a certain element. Now, someone always asks, well, what if if its number of protons changes? Well, then it is no longer that element. Like if hydrogen were to somehow gain another proton, it's no longer hydrogen, it is now helium. So that's really important. Again, the periodic table is arranged by these atomic numbers, thanks to Henry Moseley. And in an electrically neutral atom that doesn't have an overall charge, the number of protons, this atomic number, is going to tell me the total number of electrons. So that's something to keep in mind. Something else you'll see is a symbol, and this is just an abbreviation for the name of the element. And so these are not something that you can just make up however you choose. These are known abbreviations that are used by all. So like hydrogen is abbreviated by a capital H. Lithium is the capital L, lowercase I. So it has a very specific way of being written, and that'll be important as we move forward into our bonding unit and start talking about compounds. Now, another number that's really important is the mass number. Now, this is not on the majority of all periodic tables, this mass number. You shouldn't really be seeing this on a periodic table, but it is something you need to know. It tells the number of protons and neutrons in the nucleus of an atom. And we call this the mass number because remember, that's where most of an atom's mass is located. It's in the nucleus. So the number of protons and neutrons is really telling me about the mass of the atom. So, for example, look at the pictures of each of these atoms. These are Bohr model drawings because my electrons appear in fixed orbits. And we'll learn how to draw those in Concept 3. But what I want you to do is find the mass number of the following atoms. So looking at this, C stands for carbon. Carbon always has 6 protons. Now, 6 protons plus 6 neutrons means the mass number is 12. All right, fluorine. Think about it. The mass number is 19, because 9 plus 10. All right, now think about calcium. And it is 40. All right, awesome. Now, using what you just learned, I want you to be able to fill out charts like this. So I would give you something like this on an assessment, and I would give you a periodic table, and you would have to be able to fill out the information on it. So something I think that helps is before you get started, I like to write above the top, how am I going to figure out what each of these things are? Where do I look to determine these things? And then you can start processing through those. So the atomic number, it's on the periodic table. So to find the atomic number, you're just going to look on the periodic table. The mass number, remember we just learned that is protons plus neutrons. So whenever you figure out protons and neutrons, then you'll be able to find our mass number. Protons is always the same as my atomic number. So those will always be the same. Now to find neutrons, I take the sum, protons plus neutrons, and I subtract the number of protons to get just neutrons. So these two numbers should add up to this number. And then remember, for the number of electrons, it will be the same as the number of protons in electrically neutral elements. And that's all we'll be working with in the meantime, is electrically neutral elements. So I'm going to walk you through this first row in terms of how you'd figure this out. And then I'm going to skip through really quickly because I really want you to try to figure the rest out on your own, and then just pause when you're ready to check your answers. So for this first one, I tell you the element is aluminum and it has 14 neutrons. Okay, well, what should I do? Well, look at aluminum on the periodic table because that's how I figure out the atomic number, which is 13. Now, because I know the atomic number, I also know the number of protons, so I can write a 13 there. To determine the mass number, I'm going to do the protons plus neutrons, which is 27. And then last, to determine the number of electrons, that's just going to be the same as the number of protons in an electrically neutral atom of an element, so it will just be 13 also. Alright, so I'm going to click through really quickly through all these answers, and I want you to do it on your own and then pause when you're ready to check. Alright, so with that background information, now we can talk about what isotopes are, which is what this concept's really about. So, not all atoms of an element are actually identical. And this was a mistake of one of the scientists from our Concept 1 notes. So you can go back and see who thought that they would all be identical because they were not quite right. So isotopes are atoms of the same element that have different numbers of neutrons. Now, the atomic number has to be the same for it to be the same element. Remember, the atomic number is the identity of the element. But because the number of neutrons is different, the mass number is going to be different. So, for example, hydrogen 1 versus hydrogen 2. These are pictures of it. Hydrogen 1 has 1 proton in the nucleus, and it has 0 neutrons. So 1 plus 0 means the mass number is 1. In this picture, we see hydrogen 2. Hydrogen 2 has 1 proton, just like hydrogen 1, but it also has 1 neutron in the nucleus, and 1 plus 1 makes the mass number 2. Now, lower atomic numbers, usually less than 20, tend to be most stable when the ratio of protons to neutrons is 1 to 1, but that's not always the case. But I do want you to know that the number of neutrons does affect potentially the stability of the isotope. So that's important to note. Now, going back to that, that means this atom would be more stable than this one because they have the same number of protons and neutrons. All right, some notation. Because you can't determine neutron number or mass number for the periodic table, there's a certain notation that has to be given to you in order for you to be able to discern things about an isotope of an element, because you can't know the different mass numbers of them. So we have two ways of writing out the notation for an isotope: hyphen form and nuclear form. So, hyphen form. It is the name of an element hyphen the mass number. So for example, potassium hyphen 40. This means that this would be an atom of potassium with a mass number of 40. So let's break that down. Look at potassium on your periodic table. What is its atomic number? Its atomic number is 19. So that means that this atom, this isotope of potassium, has 19 protons, because all atoms of potassium do. But it means it has 21 neutrons, because the mass number 40 minus 19 is 21. Now, another way we could write this is nuclear form. And this is the symbol of the element with the mass number kind of superscript in the top left corner. So to write potassium 40, we would write this little 40 and then the K, which is the symbol for potassium. Now, something to note is that nuclear notation can also include the atomic number below the mass number. So you could technically put a 19 right here, but it's technically not necessary or essential, because if I know potassium, I can always look on my periodic table to determine the atomic number, which is 19. If I know 19, I can always figure out it's potassium. So having both is a little bit redundant. So for my class, you only need to make sure you include the mass number. All right, let's try 2 examples. So for each one, I want you to write the hyphen form and the nuclear form for each example. So looking at this first one, this is boron. The B tells me it's boron. And 5 plus 6 gives me a mass number of 11. To write that in nuclear form, that would be 11 and then the symbol, which is B. All right, example 2. Na stands for sodium, and 11 plus 12 is 23. So the hyphen form would be sodium hyphen 23, and the nuclear would be 23, and then the symbol Na. I will have y'all do charts like from this page with isotopes. And you'll have to write hyphen and nuclear notation. So we are going to practice that, but it's the same idea, except for I'll have to give you some help with the mass number, number of neutrons, because you wouldn't be able to necessarily look that up on the periodic table. All right, last thing I want to mention is the last number that you may have noticed on your periodic table, which is a decimal number. And this is the average atomic mass. And some are more specific than others. Technically, hydrogen's average atomic mass is 1.0079, but a lot of periodic tables round it to 1.01. So really, really close. But this is a weighted average of all the different versions of an element. Okay, and remember those different versions are called isotopes. And so because it's a weighted average, it's going to tell us what is the most common isotope of the element. So for example, the average atomic mass of hydrogen is 1.01. So rounding that, that means the most common version of hydrogen in nature that exists is hydrogen hyphen 1, which would be 1 proton and 0 neutrons. Look up carbon on your periodic table. It has an average atomic mass of 12.011. That means the most common version of carbon is carbon 12. Carbon always has 6 protons, so that means in the most common version it has 6 protons and 6 neutrons. Other versions of carbon exist. There's carbon 13, carbon 14, but carbon 12 would be the most common version. So that decimal, that average atomic mass is helpful. If I ever ask what's the most common version of an element, you can look at what isotope is the most common. You can look it up on the periodic table using that average atomic mass. All right, now we're going to practice.